Right, good evening, welcome to Dreadnought Customs. For some reason, the last video, well, part of this video didn't record properly. It's cut off the front of it. So apologies for that, but this is a kind of interview, talk with a chap called Paul Compton, who's rebuilding his old electric powered VW Scirocco Mk2. I don't think you missed a great deal off the front, but if you want to see more, want more information, and also this chap's really into his old little Italian motorbike, so there's lots of other cool stuff on his page, or yeah, on his page, whatever you call it. Channel, that's it, on his channel. So yeah, I'll put a link below and hope you enjoy this. Hopefully I'll go and meet him again when he's further along in the build, get more information. But there's quite a bit of information on his page as well for or his channel for yeah, more info on this build. So hope you enjoy. Thank you. Bye. This video is not going to cover barely any of what the build's going to entail.
The work I was doing today was I re-welded that repair.
Yeah.
And
so there's quite a few little repairs and holes.
Yeah, and I've just been making a
panels, yeah,
panel for there.
So I see you've been attacking the sills as well.
Yeah, we can have a look at the sills. The latest video.
Got to get a rotisserie. Ooh. Okay, so first of all, how did you get all this undersill off?
Wood chisel.
Wood chisel?
Yeah.
Heat it up or anything like that? Just a wood chisel?
Just a good sharp wood chisel.
Okay, cool.
Buy a cheap set.
Yep.
And you just want to, it doesn't want to be super sharp, it just wants to lose a little bit of its edge.
Okay.
So it doesn't gouge too much.
But yeah, that's a lot of that's come off quite well. I mean, I imagine it's a bit of a tedious job, but...
It's the thing I do when I'm stuck. But you know, this started as a tiny hole on the inner, and then...
this was the part you actually did a video on yesterday, wasn't it?
That's the latest video.
Yeah, I watched that today when I was on my lunch break, obviously at work.
So there's the...
So yeah,
that's the new inner sill.
With the jacking points.
With the jacking point, because somewhere around here there will be the...
Yeah, they're all crossed out on the bottom, don't they? Where people
yeah, because I think
jack them up and...
that's something that's not in the Golf. As far as I could tell, it's only in the Scirocco.
Okay. So see, there's the normal parts of the back here are gone as well.
Yeah, but again, inside it's excellent.
To be honest, it looks better than my GTR. Mine was alright, crusty. I've got to redo all mine again. So yes, there's quite a few bits welded up. So the plan is, I'm guessing your plan is just to get all the shell solid, and then start the EV rebuild, is it?
Yeah, it's probably going to end up having to be dry built.
Okay.
So I don't know exactly how I want it to go back together as an EV.
Okay.
I'm not totally certain of what battery configuration I'm going to put in it.
Mm-hmm.
I think I'm probably going to build it as 30-40 mile range, sort of local grocery getter.
Yeah.
Keep the weight right down, so it'll get a pack from a BMW hybrid.
Okay, so you'll find a scrap car and get the motors and components from that, or you're going to?
No, I'm sticking with the original.
Oh, you're sticking
motor.
with this? Okay, yeah.
I'm staying old school with the DC motor.
Yeah.
Because actually, if you're talking electric dragsters,
yeah,
they run DC motors.
Okay.
Because you get very, very high stall torque. So your initial acceleration is very, very good.
All right, yeah.
I mean, yes, the latest Tesla Plaid is insanely quick, even off the line. But, you know, that's twin motors, four-wheel drive, and a massive battery pack to get the power.
Yeah, I imagine they're not cheap either, and if you've already got a motor sat there,
yeah,
which is good enough for...
That motor, I believe, cost me $1,500. At about $1.65 to the pound.
Oh, okay, that's not too bad then.
And about $300 air freight.
Yeah.
Because it was quite reasonable back then.
Yeah, it's not these days. I imagine something that. Yeah.
But
These days would be like that.
Probably 1999.
So you're using the same gearbox again then? Is it?
I use the same gearbox again.
That's a manual, yeah?
It's a manual 5-speed.
Okay, so is that okay with the torque, or you got to be a bit careful? Because I know the diffs can be a bit touchy at times, can't they?
The clutch is the torque limiter.
Yeah.
It would slip the clutch in third gear if you gave it too much throttle.
Okay. So uprated G60 clutch then, or
stock clutch?
Stock clutch.
Yeah. I did actually want to take it around Anglesey race circuit.
Okay.
Pre the re-layout, so it's the old Anglesey layout.
Right.
In horizontal rain and standing water with passengers.
Well, that's Wales for you.
1 minute 17.
Is that good? Oh,
well, to put it in context, fifth gear were using it as their test track, and Tiffany Dell was getting like a Renault Clio 172 around in about 58 seconds in the dry.
Okay, so it's not quick. I mean, you've got the wet weather to take into account as well, but that's still going some.
Yeah, I upset a local multi-point injection Cooper S owner because that was quicker than he'd been around.
Ah.
And I said, yeah, I'd have been quicker if I actually bothered changing gear.
So I suppose with a big torquey motor, you can just leave it in a gear and then it will just pull away with it.
Third gear was good to about 70 miles an hour. Second gear, if you were in town, and more efficient to pull away in second, but quite happily pull away in third. To be honest, it would pull away in fifth, but
So what kind of RPM would the motor spin at then?
I would take the motor up to about 6,000.
Oh, so that's pretty much the same as what you get from the original.
Not far off. I developed this idea of keeping the current down and using much more voltage than the motor was originally rated for. Okay, what would the benefit of that be? You get the torque further up the rev range. So you get less torque, but you get it flat further up the rev. Oh, so it's a more linear power delivery. So it's a flatter. Yeah. Okay, no, that's cool. So yeah, I'm a bit of an electronic noob as such. I'm more of a mechanical based mate. Well, I mean, this was stuff I developed on the Porsche race car. Everybody else was going relatively low voltage and high currents. And so did that cut down on the cable size as well? It helped with cable size. Back when I started the racing, everybody was running low rolling resistance tyres. And I was saying, no, we need better tyres and we need better brakes. Better brakes mainly because we're going to be, not because we're going to slow down for corners, but to keep out of other people's way because they're slower. But to not, rather than, the idea was to carry as much speed through the corner as possible so you didn't throw energy away accelerating out. Yeah. So where everybody else was low rolling resistance tyres and didn't care much about suspension, they had to use more energy getting out the car. They were using more energy coming out the cars, and it was we actually kept turning our power down because we were running spreadsheets and a two-way radio to the driver to say you're on your energy budget or you're not using enough energy, go faster. Okay. Almost Formula One style, continually recalculating. And we never won a race, but we were getting on the podium a lot, up against teams with 10 times the budget. Well, that's good going, isn't it? I mean, to be honest, do you have fun? Yeah. That's the main thing, isn't it? Yeah, and I'm still in touch with some of the people from all those years ago. Yeah. Cool. So back to this one. What are you going to think? What do you think it's going to weigh then? Is it going to be a huge? I mean, obviously the motors, I'm guessing, probably a little bit lighter than the standard engine. I can't remember what it weighs, but it's lighter than the original engine by a fair chunk, actually. Yeah. I know. I weighed the car where I used to work. Actually, had a weigh bridge. That's handy. So in lead acid form, it was 1,200 kilos. So that's about 300 kilo more than standard as such, so two fat people. Yeah. So, And I would, with the lithium pack, with the BMW hybrid modules, I'd probably be down to 1,000 kilos.
So that's about 100 kilo more than standard. So really, that's not a heavy car.
No.
And the weight distribution, I'm guessing, is going to be a little bit further back.
With the lead acid, it was better than stock. It was getting very close to 50-50.
Oh, was it? Okay.
Yeah. That's one of my kind of design choices, is I can easily put all the batteries in the front battery box.
Mm-hmm.
And that's much more convenient electrically.
Yeah.
Or I can put the rear battery box back in and put some batteries in there. Or I could actually put a second set in there to give more range, which would also start balancing the car more 50-50 again.
Okay. So what about the control then? The control of the electrics and stuff. I'm guessing you've got a like potentiometer on the throttle pedal and
a remote one. It had a cable to a throttle box.
Oh, okay. So
it might get like a Toyota Prius pedal.
Okay. Yeah.
Instead, because that's the problem with cable-operated ones, is you can run into problems with jammed cables and things.
Yes, I imagine. Yeah, I imagine that's an issue.
Which you don't get on a fly-by-wire pedal. And then the motor control. The motor control was pretty much cutting edge at the time.
Self-designed? Self-made?
Not self-designed. You've heard of sacrificing parts to the gods of speed.
Yeah.
Motor controllers are far worse.
Okay.
Back in the 90s, the transistors, either MOSFETs or IGBTs, were much more fragile. So you try and build a high voltage, high power motor controller, and if it failed, it's a bit like a crashed aircraft. It tries to destroy all evidence of why it failed.
Yeah, yeah.
So, anybody who's done motor controller development back then would have a huge pile of charred components where the magic smoke had escaped.
Yeah.
So there were a bunch of Hewlett-Packard engineers who were moonlighting doing motor controllers. They called themselves Auburn Scientific.
Right.
And they first came out with a motor controller they called the Kodiak. And then later with the Grizzly.
Right.
And the Grizzly was running close to 200 volt and 680 amp.
Okay.
And I was able to get one at a trade price.
Did you know them then? A couple of packets of biscuits.
No, the guy who, Mike Slominski, Mike's Auto Care in San Mateo, that's where we prepped the car.
Right, okay.
He was like the team manager.
Yeah, this is the Porsche you built.
This was the Porsche 914. I was chief mechanic, only mechanic.
Yeah.
So I did most of the prep. Mike would do the parts ordering. The car was owned by a lady called Claire Bell. Mm-hmm. The first year I went out there, I stayed with Claire up in the Californian mountains in a trailer home.
Nice.
But then I started staying with Mike because it was much closer to the workshop.
Oh, cool.
And 4 years I did it. I went out there 5 weeks out each year. Still in touch with Mike fairly regularly and some of the other guys from the racing scene. And it was a lot of fun. And we were pushing boundaries in terms of what was possible back then. And
So do you still develop electronic stuff? I'm guessing you're an electronics engineer by trade.
I was for 32 years. I still do bits and pieces. I mean, there's much more off the shelf where you can just combine other people's modules into systems rather than having to do everything at component level.
Yeah.
But certainly for the other projects that I'll be doing after this, that's open source AC drive systems.
Right. Okay. So that's the next. Is that then kind of basically the next step up? Is it in complexity?
Yeah. The induction motors and the synchronous AC permanent magnet motors is what's used in all the modern electric vehicles.
The three-phase ones, yeah?
They're generally three-phase. Tesla are more traditionally used induction motors. Nissan and BMW use permanent magnet synchronous motors. So I've got a couple of Leaf motors. And the Leaf inverter, you can either drive with CAN bus traffic,
Yep.
but you're limited to the power limit programmed in by Nissan.
Okay, that doesn't sound good.
Well, that's 80 kilowatts. That's about 115 horsepower.
Yeah, you want more than that, don't you?
Well, the latest Leaf is 217 PS.
God, what's that in BHP?
About
170?
213, something
Oh,
like that.
That's a fair amount then for...
Yeah. I mean, that's a 1,700 kilo car that does 0 to 60 in 6.5 seconds.
Yeah, so in whatever you're sticking that
So
in...
in something like this, down at 1,000 kilos, it would actually be
swift, yeah.
decently quick. But you can pull out the Nissan logic board and fit an open source logic board, and then it's how hard you dare drive the silicon before it
before it melts,
spontaneously explodes.
Yeah. Cool. So what's the next things for this then? So as you say, you're going to build it up, dry run it. Any idea roughly when you think you're going to have it back on wheels?
Well, I'm going to dry build it just to do component layout, really. You know, just work out exactly where everything's going to end up going, what battery configurations I'm going to do.
Yeah.
You know, it used to have a cable tray running down the centre tunnel. And if I put batteries in the back, I'll have to put a new cable tray back in. But I've got to get the majority of the shell sorted.
Yeah, you don't seem too far off, to be honest. I mean, you've got most of it chopped out. I can see the other side you've not really started on yet.
No, I've got some work to do on the other side. It has, of course, got all the standards. I
like the stripe.
Got the standard frame rot. This arch is a bit frilly.
Yeah.
One of the annoying things is the other wheel arch is almost entirely rot free.
It's at the back a little bit.
But it's rippled. Someone's obviously brushed the car up against something. It was like that when I owned it. So that might be calling one of these paintless dent removal experts to see.
I know a chap who sells repair panels, arch repair panels, if needed.
But this is so solid. I mean, there's just no bubbling at all. You kind of say, if I can straighten it, it would be better to straighten it.
Ooh. So yeah.
But
this is what the underside of a Scirocco looks like, by the way, if nobody's ever seen one.
And of course, the purpose for your visit is to see if I can use your
my puller, which
stud welder to pull the
never
creases.
actually used before. I got given it a few months ago, and it's just sat there waiting for a play. So yeah,
it's not terrible, but if I don't do something about it now, it'll annoy me.
Yeah, you might as well try and pull it as well. There's no point gobbing it up with filler because it will just that's just no good, is it? Cool. Right, so I'll call it a day for the video then. But no, thanks, Paul. Hopefully I'll pop down again and see you in, don't know, 6 months, a year or so. See how you're getting on. But if not, check out Paul's page, his channel. I'll stick a link below in the description, in the bio stuff. And yeah, I don't think there's any other sort of electric Siroccos being built in the world. Not that I've heard of, anyway. So.
There were a fair few in America.
Oh, was there?
Yeah.
And you get finished though?
Oh yeah.
Yeah.
Yeah. I mean, in the electric vehicle racing, there was a high school class.
Oh, okay.
And there were a couple of Siroccos in that. Mostly it was rabbits.
Yeah.
Diesel rabbits.
Diesels?
Yeah, because Americans don't change cam belts.
No, that's true.
So there were an awful lot of dead Mark 1 Golf diesels that had broken cam belts that got donated to high schools and stuff. But I mean, there was, Fieros were popular for it, and that was the kind of distinctive stuff. There was all sorts of other stuff, but I'd have to look through the photographs, the old-fashioned photographs.
Well, I've learnt something new today then, but yeah, we'll see how you get on, and hopefully we'll see it at a couple of meets at some point, maybe.
Yeah, well.
No, yeah, it'd be good to see it go down a drag strip at some point.
Yeah, I don't know. It'll be particularly fast, but
No, but it'd be interesting.
embarrassing.
It'd be interesting to see what it does, though.
Yeah.
But yeah, it'd be cool. Right, so thank you very much, Paul,
Wow.
and that's all from me. So yeah, I'll see you whatever. Cheers, bye.